All right, well, let's get started. Ooh, excuse me. Allergies have been rough lately. Let me turn the music back on. There we go. All right, so last time we were going with a certain, we were designing all of this for a certain type of case, which as you can see here, let me pull up here. This is a good view. This is the case that I've just pulled in. Originally, oops, not that part. Where's the bottom? There it is. Originally, I was going to use this case, which was much shorter. And I was having a hard time making the buttons fit. Excuse me for a sec. So I decided, we went online and looked at the company that I'm going to order these from, and they actually offered the same form factor. Let's see if I go here and zoom out, I can take this. Oops. Take that off, and then add this bottom piece in and take this one out. And you can see that nothing's really changed. So there's a case that already exists with the exact same form factor. It's just taller, which is good because it means that these buttons that we picked out can actually fit. You can see that they're actually quite a bit bigger than we had originally anticipated. But there's actually some space down here now. So I'm excited for that. But what that does mean is we need to change the height of this PCB because these switches, which I have some here, have a set height. And we need to make sure that this plastic switch piece is obviously above the case so you can reach it. So we need to get the PCB at just the right height for that. And the way we're doing that is with washers and standoffs. So these standoffs here in the middle to hold this side of the PCB in, and then on this side, and ignore the double stacked screws there. But if I turn the PCB off, yeah, okay, so you can see the washers here and then the screw where that mounting point is. So we need to make this taller because the case got taller. Which means redoing some measurements. So that's the first thing I'm going to get started on. And actually, I forgot to adjust that in our goal. So let me do that first. But feel free to just hang out and watch or offer suggestions, or just let me know how your Tuesday's going. Talk about whatever. Or try and claim one of the bounties. That's an option too. Okay. Man, is anybody else experiencing allergy season like crazy? Like I have, it has been getting to me. All right, I think that's good. Yep. I'll stop focusing on the stream. Okay. So I think we are definitely going to go with this new case. So I don't see really any reason to keep the old one. The new one, let's see. Yeah, the bottom of the old one is in the same place as the new one. So I think this is fine to delete. So that'll delete a bunch of components. Yep, so that gets rid of our double screws and everything. But now we need to change our standoffs to match everything. And first things first, we got to figure out how high these switches need to be. So if I grab this, so here's the switch without the top on it. This height right here you can see, is 15 millimeters. Sorry, I'm trying to block the mic when I do that. But yeah, this height right here is 15 millimeters. So we need to really get it just the top piece, just a little bit of the case. The rest of it needs to be kind of hidden down inside. We want these switches to be low profile. However, we can't just go off that measurement because once the switch is on, that distance is actually a lot shorter. So I need to figure out what that is first. So I'll measure it real quick. I guess I should measure in inches since everything else is done in inches. One of these days I'm going to find a way to buy only things from companies that are in metric, and that is going to be a good day. All right. Looks like 0.3, so 377 mils, 0.377 inches. And we don't want the plastic pieces here to be touching the plastic casing, so we need a little bit of clearance there, probably about 20 mils or so. So that being said, we probably need to probably actually need to do the math on this. All right, let's see. First things first, I need to do a conversion. $15 millimeters to inches. So 0.591 inches. So, or 591 mils minus, what we say? It was to the switch, it was 377, but we wanted 20 more, so minus 397. So 194 mils. So what this means is that 194 mils of this black section must be above the case. And we will keep raising the PCB until we get that. Unfortunately, with the way some of this stuff works, it kind of has to be eyeballed. I'm not good enough with FreeCAD yet to just measure everything out. All right, so I guess we need to turn the top of the case back on. There we go. And let me save this number because I will forget it. All right, 194 mils above. And there we go. All right. This PCB. No one's taken a stab at the bounties yet. Oh, shoot. I was showing my screen for some of that. All right, well, here it is. All right, let's raise this. So we need to go up on the Z. Well, heck, let's just try 0. Already looking good. What does that put us at? There to there. 128 mils, and we said 194, right? Yep. So we subtract 128. 66. So we need to add 66 more. So 0.0, whoops. 0.066. Okay. Let's delete this measurement. All right, so this puts our PCB where it needs to be at. Now you'll notice that it's sitting off of the standoffs a bit. So now we need to go take all of that into account. There is some math to be done here. Ooh. I apologize. I'm probably going to be coughing a lot tonight. Okay. Let me go look up this item that we have picked, this new case that we've picked. Okay. Here's the website. By the way, these guys say that they can machine it and print it for you, so we might look into that option for this. Although I don't know how expensive it's going to be. Or how long it'll take. Okay. It was SL something. I think I can do some filters. Width, height, no, length and width. 6, 4, apply. By 4 by 1.5. I think this was it. Oh, you know what? It's probably marked in the part number here for the model. Yep, the 68p. Okay. So this one. And then I probably already have the drawing for it. Where is it? 64. Oh, maybe not. Okay. We want this. Here we go. All right, so this is the drawing that gives us the measurements on the inside. I'll move that out of the way. So this will help us determine everything that we need to figure out for all these distances. Okay, so let's do this. First things first. I'm going to turn off that and turn the top of the case back on. And then I want to figure out these interior distances. I wonder if you can even do this. Oh, you can. That's cool. Oh, no. As soon as I move it, though, it doesn't work. All right, that's fine. I was just trying to figure out what the inside distance was to the bottom of the circuit board. We can do this from the drawing. We know that there's 194. Actually, let's double check that number. It should be 194. Yep, 0.194. Excellent. Okay. And then we need to add the thickness of this, and we take that away from the total length. All right. Good. So let me pull the drawing up. Okay, the thickness of the top case, we want the recessed thickness. It's 0.110, but the recessed version is slightly different. 0.03D. So in mils, 110 minus 30, 80. So it's 80 mils thick plus 194. So 274 mils. And then what we say 15 millimeters was. 591. So 590. Whoops. I just lost it all. Okay. 80 plus this. 274. Save that. And then 591 minus this value. 317 mils. So take the top case off. 317 mils of this post is below the case. Now we need the thickness of this piece right here. And let me make sure this number is saved. Yep. All right. From there to there, 0.254. So add that to the 317. 254 equals 571 mils. Or, yeah, so just over half an inch. So that is the distance from the top of the case down to the circuit board, which is what we're going to need for this standoff right here. What is this particular standoff? All right. I've got McMaster up here. Nope. 9107. Here, let me just pull in the other window. (9107) 5A435. Five A435. Here it is. It is 7/8. So that's too big. So we can't use that one. I guess we gotta find the closest. So everything done on McMaster is done in fractional inches. So we need to find the one closest to 571 without going over. Excuse me. So it's going to be just over half an inch. We're using 440s. Think, well, there's half an inch and then 5/8. 5/8 would be too big, wouldn't it? It'd be like 0.625. Yeah, that'd be too big. So I think we got to use half an inch. 9107, 5A103. There's no chance we've already included that, have we? Nope. Okay. All right, I'm going to delete this. And then we need to delete our other top standoffs probably. Yep, that one. Let's delete that and delete that. Just got to get rid of everything we don't need. Okay. All right, and then this is the one that I'm tentatively using here. Actually, wait. .3/16 hex size. Can we go to a 1/4 inch hex size? Does that give us more options? Half inch, 5/8. No, it still gives us the same. Let's use the 1/4 inch size. I like that better. So this one. Alright, so if I go back to this, I believe these are the 1/4 inch ones as well. Alright, doesn't look like we've used that, so I'm going to go ahead and download the CAD model. And then we need to import that. Alright, that ended up somewhere. Let's rename this. And then we need to duplicate it. Because we need 2 of them. Okay. Now where is it? There it is. So, alright, you know what? Actually, let's just start with this one because we're going to have to adjust some things. Axis, we need it on the Y. 0. Angle 90. Okay, that's a good start. You can see it's standing upright. Alright, now let's see, where is this part at, position-wise? 1.378 and 0.740. 1.378 and 0.740. There it is. Alright, so now we need to get it up high enough. Alright, Z-axis. Too high. 3, 2, 5. Alright, we're in the right vicinity. Let me get... There we go. We're gonna need this to be pretty close. There we go. 0.25. That's probably pretty close. Alright, so now we need to duplicate that. And then this one, the x-axis becomes negative. If we go back here, we can see that it's appeared over here. Right there. So now we got both of them. All right, excellent. You know what? Actually, this might be wrong. We decided that... Excuse me. We had to use a smaller size. We used a 1/2 inch and it's 0.571. How thick are these washers? They're not super thick. I think we put a washer on here. Because we've left like 70 mils of space, which isn't a lot, but it could like clunk around. Yeah, they're 20. All right. What is this part? 90107 A005. Actually, I probably have this in the BOM. Yep. Thickness can vary from 0.024 to 0.038. If it's 0.038, 2 of them is too much. But 0.024, 2 of them would be enough. Let's just start with 1. We can always add another if it becomes necessary. But yeah, I think this needs a washer on it. Unfortunately. So, all right. So this gets raised by 0.24. So it becomes 4.9. 5, we'll round it out even, make sure everything fits. This one too. All right. And then these washers need to go up to meet that. Let me get rid of the bottom case here, turn it off for this. Like that. Thank you. 0 is right there. 105 6 7, pretty close. There we go. That's the right height. All right, and we need to do that with the other one. .067. All right, excellent. We're getting there. We're getting there. You know, kind of. All right. Yeah, all right, so that works. Let me update the assembly with it. Whoops. Here we go, this. The middle top standoff becomes this new one. All right. Now we gotta do this one, the middle bottom. So we should be able to figure out the spacing required based off of this number. So we know 571 mils between the top of the case and the top of the PCB. The PCB is 62 mils thick. So we can add that. 633. So that's from the top of the case to the bottom of the PCB. Now, if we pull up our drawing, this drawing in particular, we should be able to see how thick the interior is. 1.286. So 1.286. Well, actually, probably need 1286 minus this number. Gives us 653. 653 is the distance from the bottom of the case to the bottom of the PCB. Or roughly 5/8, I believe. 5 divided by 8. 0.625, 653. Yeah, that's pretty close. We can actually do that without a washer. Okay. So we are going to pick a standoff, a threaded standoff that is 0.625 or 5/8 long. So here we go. Let's go back to the home page here. And then spacers and standoffs. Round threaded standoffs. We want fully threaded, 5/8, probably a 1/4 inch in the outer diameter, and it needs to be 440. Oh, they have 9/16 as an option. Here we go. This one right here. $214 each. Jeez, these things are expensive. All right, 5/8 long, fully threaded, 1/4 inch all the way around the outside. Inside is a 440 thread, so it'll tighten in just fine. All right, excellent. So let's add this to our model. Download this step file. And then we'll have to get rid of these ones. There he is. Hidden underneath there. So 1.378, 0.74. There we go. And now we need to lower it down into the right height. So really, just until it's against the bottom of the PCB. Does anyone have any questions so far? All right, I'm going to rename this real quick too. And then this one needs to get turned off. This one too. Okay. Oops. Negative 0. That's pretty close. Negative 0.32. I guess we could have worked that out because we could figure out the halfway distance of that total. If it's 653, you do this divided by 2, because these are set off the midpoint, so 326.5, that would be halfway between the board and the bottom, but 32 is fine. All right, let's duplicate that and do that on the other side. Change this one to negative. And then we can delete these ones that we don't need anymore. And then finally we need to add this to our parts list in place of the existing one. There we go. Washers are good. So the last one is these standoff screws, and we'll probably have to add more standoffs. Well, we're going to end up buying a lot of stuff for this. It's going to get expensive. Okay. So these screws got to change because they're not going to be long enough. And then we need something in between here. We might be able to get rid of these washers, or we'll more likely just have to move them. We got to get the distance from the bottom of the PCB to the standoff. That'll be a good start. So how tall are the mounting points? 0.25 inches. So distance from the bottom of the PCB to the bottom of the case. Minus 250. Use this with 403. What is the closest fraction to that? Let's start with the standoff. So 0.403. For this one, I'm not going to use a threaded standoff. Let's back up here. We're going to use instead of what's a standoff, we're going to use what's called a spacer. The only difference being spacers are not threaded. Aluminum unthreaded spacers. These are pretty cheap. All right. We want 1/4 inch diameter for number 4 screw. That inner diameter is a little too small. Maybe a number 6. Yeah, probably number 6. And then what's the closest fraction to 0.4? What's 5/16? This is where I need a chart. Maybe there is one. I can just Google real quick. Fractions to mils. I just want a table. Here we go. I don't know if I can show this on screen because copyright stuff. So we need as close to 403 as we can get without going over. Looks like 3/8 and a washer it is. Because I don't think they have 25/64. All right, 3/8. Where are you at? Here we go. I think we decided we're going to use a number 6 size screw so it's not too small. This one. 27 cents each, man. These things are cheap. You know, I'm actually a little hesitant about using this one with the bigger diameter, because although it would fit the screw, I'm worried about how much it could move around. What are the screws that we're using? What's their diameter? See, it's 0.127. So using the, and that's because these are not necessarily, these aren't machine screws. They're not designed to fit into that. They're thread forming screws. They're going to cut into the plastic better and hold better. So the risk is there's an extra space, about 5 mils, 6 mils on each side of it. That's not very snug, which isn't a whole lot of distance. It's very tiny, but it might still be enough that this thing, like if it's these holes right here that are not held very tightly, and on this side, these ones are not held at all. They're free. So the entire location of mounting of this PCB, like side to side, is dependent on these two screws. And if they're a little loose, this could wiggle around and move around. And if it's tight, it shouldn't. But if it comes loose, it will. So do we risk the bigger standoff, or do we risk going with a machine screw? The problem with a machine screw is sometimes in plastic, especially because they don't cut very well. They can get kind of jammed in there, and I've actually had them snap before, depending on which one you use when you're trying to like pull them out. If we make this really tight, it should be fine. Yeah. Any thoughts on that? Anybody? Let me look at machine screw. Just give me a standard. $440. I guess we just pick any of these. Yeah, 0.112. It's much thinner. What's the diameter of the hole on this case? Because that'll matter too. Interior diameter is 0.090. Okay. And the screw would probably go in just fine, but I don't know. Maybe this is the right option. Maybe we go with a 440 and go with that. I think we do. I think that's the safer bet. All right, let's do that then. I'm not hearing anything otherwise, so. All right. So it's like 1/4 inch diameter, number 4. What size were we looking at? I forgot already. 3/8. That's right. 3/8 number for this one. All right, we'll download this one. And then we need to add that in here. And I think we're going to have to have one washer as well. All right, it's like hidden in here somewhere. Yep, there it is. So 1378 negative 2.380. All right, what was the screw again? Negative 2.38. And then we will adjust this. All right, excellent. And then I am going to turn off a lot of this stuff. So I can line this up. There we go. And we need to adjust the height. We could probably figure out the distance, honestly. That's all right, though. Just go for it. It's more fun that way. Oops. Oops. 1. That's probably close enough. 0.19. All right. And then we will duplicate that. And we need to change the X to negative. Ah, we're getting so close, man. All right. So that should be fine. And then if we pull in the bottom case, I think that's that. Yep. Did we get that right? It looks like it. Question is, how much space is there in here? There's going to be some at least. But I can't see it very well. I don't know how to do that. I need to do some sort of like cross-section view or something. Okay. Oh, yeah, you can see quite a bit of space in there. Yep. I think we'll be okay to add a washer. I think we should. Right on the bottom of this. So, all right, let me turn this off. And let's see, let's lower this by 0.24 or 0.024. So negative 214. And then we should be able to raise the washer to be right in that space there. Turn this one off. There we go. Oh. All right. It's going to be a very small amount of movement. Yeah, right there. 0.025. Fits in that space perfectly. All right. I don't think we'll need another washer. Let me turn on this again. And then, yeah, I think it's okay, but I think we're good. All right, so now I need to do that to the other side. Let's see, where does this washer where I want to bring this washer from? Yeah, I'm gonna delete these two. And then change this one to a positive X. I guess I could turn it on to see what is actually happening. All right, and then minus 25,000, so we'll adjust that to the same here. Okay. Excellent. And then I need to make sure we update. So we got to add a section here. Mounting standoffs. And then we need to put a link to these ones. 3/8. Yep, that's correct. All right, and the washers, we can drop down the quantity because we only need 4 now. All right, cool. So that's almost everything. The last thing I think is the screws, right? Yep. And so we need different screws. Ones that will actually go down into the case. Let's see if our case drawing here tells us how far down that hole goes. It's probably the whole 0.25, honestly. But I don't think it tells me. All right, well, we'll have to figure that out then. So, good screw size. Let's see. Storage that number just in case I need it. So we need mils. We need 62 for the thickness of the board, plus 3/8, which is 375, plus the thickness of the washer, which is at least 24. So we need something that's at least that, the 461. Plus a little extra to actually like get to. Honestly, it should be probably 43 plus 62, right? 470. A half inch would be really good. I think that would be enough. Let's find a half-inch screw. So a half-inch 440 machine screw. Oh, those are expensive. I think that's what we want. What's the next size up for my half-inch? 9/16. Oh, that's not 440. Yep, 9/16. What is 9/16 in mils? .5625. That's probably better. We should probably do that. Let's go with a 9/16. All right, so this will be good. We can just just do something. What is this? Oh, that's that standoff back there. That's probably fine to leave on now. I'm gonna delete these extra distances. All right, we need to import that. Where is it? There it is. Oh, it's already right in the right orientation. Look at that. All right, 1.378, negative 2.38. Okay, there it is lined up. Clearance looks good. It's good on this side as well. Yep, it's really close, but it's like right where it needs to be. Oh yeah, because that's the hole anyway, so. All right. Actually, this one is probably the best view. And then we need to move this down. Wow, honestly, that ½ inch was pretty dang close. Let's go for 7, 8, 9, 5. Yeah, negative 495. Okay. So then we should be able to see. Sorry. If I turn these back on. Does the height of that seem weird to you? Anyone? It's like there's no clearance for the washer on that one. Where's the washer? Oh yeah, there is no clearance. These are different heights. 214, yep. 4. Okay. Let's see what kind of height we have on this. From here to here. 75 thousandths. We honestly could go a little bit bigger on the screw. That should be enough to grip into the plastic, but it may not be very much. I think we'll be okay though. Yeah, hard to see. All right, so we need to edit this. And then we need to duplicate the screw to the other side. And then I think we'll have all of our standoffs and screws done. There it is. All right, so look at that. The whole thing, the whole assembly, minus the top shell, obviously, is all there. Whew. All right, well, that's cool. So we have a solution for all of that, really. And what we'll do is we'll put some adhesive pads on the top and bottom of these standoffs, and that'll kind of squeeze everything into place. And I think that'll be good. All right, cool. So that's looking really good. So now we need to do... Actually, first we need to add these screws to our materials list. Here. All right, let's do those ones. Solder knobs, label and stickers, or feet, buttons. All right, this one, the cable. This is the next thing we need to model. And it is kind of annoying. So part of the other problem we're dealing with is we have to fit a cable in here, a cable mount, and it's a pretty big one, so I'm a little unsure of how exactly we're going to do that. All right, so this is the one I was looking at using because it's not too expensive, and it switches it from a USB-C to a USB micro, which was requested. All right, here we go. So the downside being how long it was. This is in millimeters. 40.5 millimeters. Which, that's a lot. 5 millimeters to inches. What is that? 1.59 inches. So over an inch and a half. And from here to here, that's not that long. This is not even going to be close to correct, but as a rough estimate, 1.665. Okay, so unfortunately, that's a heavy angle. Yeah, so that's not really a useful measurement at all. So if we go from like here to here, yeah, 1.407. So it's already obvious that it's going to be too big. And unfortunately, the gap between these buttons is not big enough. Let's see, from here to here, 0.326. From here to here, 0.385. The 0.385 is probably what we'd work with. This is 13 millimeters thick, which I think is close to half an inch. So that doesn't quite work. Yeah, 0.5 inches. Although, it does get thinner right at the end here. Down to maybe like 9. What's that? 0.35, 0.38. That could slide in there. It's going to be dang close, but it might actually fit now that I'm thinking about it. It depends on how long this section is. If there was a model for this, that would be awesome, but I don't think there is. It is an Adafruit thing, though, I think. Yep. 4056. Yeah, they don't have any kind of they don't have any kind of shoot model. Okay. Was there? Does their drawing show that this piece sticks out? It does, but it doesn't tell you how much. It shows that the USB-C port sticks out a bit, which is something we need because Or cutting through the edge of that case, but I don't know how far it sticks out. Right. Well, I think we model it and try it and see what happens. And go from there. All right, so I think we got to update our goal here for this one. Oops. Model the USB-C port. Okay. I probably should center that a little bit. There we go. No one's attempted to claim a bounty tonight. I'm kind of surprised. All right. Oops. All right, let's model this part and go from there. I think I'm just going to model it kind of looking down. So let me turn a lot of this off. Create a new sketch. I think we want XY. Okay, yep, want it down here, and then I want this off. That's an odd origin. I thought the origin was supposed to be in the middle for most of this stuff. All right, well, we'll go off the origin. I think I need to change our units here. Edit. Preferences. Units. Apply. Okay. And then I'm going to turn off these screws. Just turn all this off, honestly. Okay. So I'm going off this drawing right here. So we need to go off the end of this. We know it's 28 millimeters wide and 8.5 millimeters thick. So we're just going to make a square like this. We're not going to make a perfect model, just a rudimentary one to kind of get us started. So let's do a rectangle. And then we'll start adding in constraints. All right, so this needs to be 28 millimeters. And this one needs to be 8.5. And then a vertical constraint from, it already has a horizontal constraint. Shoot. How do I do this again? Nope. From here. Nope. How do I constrain it? I need to center it, basically. How's everybody's Tuesday going? Anything to report? I need a constraint between a point and a line. I thought there was an item for that. That's not it. Oh, I did this last time, and I can't remember how to do it. You know someone who just got a new job? Who's that? All right. You got a new job. Congrats, dude. That's awesome. That's really cool. Lines. I forget how to do this. I cannot remember. Oh, here we go. That's the one. There we go. Yeah, congratulations. That's awesome. There we go. And then we need it from here to here. And we need that half of 28, so 14. Okay, there we go. And you can see our model has turned green, meaning we've constrained everything completely. All right. And then I've got to remember how to do all this again. All right, I think it's in part, the part view. No. How do you extrude again? Line drawing inspection. It's not draft. I don't think so. No. No, that's definitely not it. All right, go back to the sketcher. Sketch. I've done that. I need to retain information better. (3D view or model view? I don't remember which one of these benches it is, though. It's the part extrude menu. Is there a part menu? Part. This button right here. This is the one I need. But I can't get it to work. How did I do this last time? Oh, no. Well, there's bonus points if anyone helps you remember. Design of him. How did I do this? Ooh, my stomach's growling. I'm starting to get hungry. That's how long we've been at this. There was some feature or function I was able to use after drawing something where I could then raise it. Wonder how many different articles I can read to figure this out really fast. Oh, okay, so hold on. Go here, select the sketch in the tree view, and then pad in the part design. Here we go. There it is, this one. It's not highlighted though. I may not have done this the right way. I might have to delete this sketch and try again, because I might have done it in the wrong thing. Delete, please. I want to delete it. There, I'll just get rid of it completely. Oh, you know what? I probably didn't have that closed the whole time, which might be why that didn't work. Hold on. I'll redo everything. Hit close. And now if I go to part design. Ah, now we can. I didn't have the sketch closed. Okay, interesting. Alright, so part design. Is this what I wanted? Hold on, something's still not working right. In order to use part design, you must need an active body object in the document. Please make one active or create one. If you have a legacy document part of the body, use the transfer function into a body. Okay. This is really what I get for not paying attention. Okay. Create new part and make it active. So we need a body. And then for this body, we're going to add the sketch in here. And extrude that. There we go. Aha. Okay, we got there in the end. Now I can go back to my drawing. Oh, wow, and it doesn't even tell me, like, how thick that part is. Alright, random guess then. Like, seriously though, look at this. It doesn't tell me how thick this plate, this big section is down here. If we look at, these are 12 millimeter screws. I was like there, so probably like 8 millimeters. Yeah. That'd probably be right. So probably like 8 millimeters, and then whatever that is, subtract by yada yada yada. Type, overall black. Yeah, a lot of stuff's just not mentioned here. Okay. Let's make it 8 millimeters. There we go. And okay. So now I should be able to do a sketch on right here There we go. And do the next section. Let me get that model back out. It's hidden underneath here. All right, so this section is 13 millimeters thick. Or 13 millimeters wide, same thickness. So we're going to have to do another one of these. And then let me turn this off for the second. And then we'll start constraining things. I know. I'm done drawing. Stop making me draw things. There we go. It's kind of weird how some of this acts sometimes. All right, this is 8.5. And then this one is 13. All right, cool. Then we can space these out a little bit, and then we need to, oops, draw some distance here, from here to here. So 4.25, then from here to here, 6.5. Don't do crap like that, you're getting banned. As soon as I figure out how. All right. Blocked. Supposedly. There we go. That's better. All right. You always got to wonder about the bots. All right, so this is done. So we can close this. And then put that up. And then I guess we got to figure out how high we want that to go. It's not the whole 40.5. I guess that would be minus 8. We should keep track of this. 40.5 minus 8 equals 32.5. So that's our remaining space, but it actually does get a little smaller. So if we're looking here at this little section right here with the stress reliever, it gets a little thinner, so we need to figure out what this total distance is. It's going to be a rough guess. I'm saying this is probably 10 millimeters, so 32.5 minus 10, 22.5. And that should be close enough for us. All right, so 2.5. Okay. And then one more sketch right on top here. And we're going to have to guess again on the dimensions here. This is why everything that they sell on these sites should have a model. Every single one. All right, same height again. So another rectangle. Whoops. No, go back. There we go. All right. And then let's turn off this. Okay. Same thing as before. So this is still 8.5. And then this one we have to totally guess on. Maybe 9? I think it's the number we worked with last time. Excuse me. And then 4.25. And this one would be half a nice of 4.5. There we go. All right, everything's locked into place. Models turn green. Okay, let me close this. And then raise this up. And I think we decided this is going to be 10. Yep. Okay. So this is our absolute, like, basic model for... for this, what is the word? USB-C port. I think there's still some stuff we probably should add the ports though, honestly. So on this face right here, we need a sketch. And we need to cut. So we'll do one circle at a time. It's going to be 10 millimeters from the center. And then the height, or the radius, we need to do a radius. The radius is... It's an M3 screw. Let's go on McMaster and just look what a number 3 screw... .099 inches. .5. Hold on, just checking a couple things. M3 of screw. Diameter. Okay, so it is just 3 millimeters, so we should just say 3. Okay. So radius should be 1.5. Okay. It hasn't turned green yet. We've set the distance from that, but I guess we do need to say an angle. How do you do that? Is there an angle? Is the angle of a line or angle of two lines? Over constrained. Let's delete this one. How do you delete it? Whoops, didn't mean to do that. No, go back to that. There we go. I guess Control Z was the only way. All right. We know that it's more or less pretty close to the right spot. But I feel like it really does need to be constrained somehow. I don't know how to constrain this. I guess I can move it up here and then do a vertical one. No, that wouldn't work. Ah, there we go. You can constrain it to the axis that way. Perfect. Okay, that looks good. So now we can close that and then pad sketch. I don't know that we want to do a pad. We want to cut somehow into this. Oh, if you do a negative value, actually, it might. Nope, it doesn't. Oh, hold on. No, negative values don't work. FreeCAD, pad, sketch, cut. All right, we'll get there eventually. There might be an option here. Oh, create a hole with the selected sketch. Why did it suddenly get way bigger? That was not what I wanted. Nope. Oh, there we go. Pocket. Length. I don't know, 10. We want to go all the way through. Okay. Done. Okay, we got there. First screw hole finished. Now we gotta do the other one. Just gotta create an identical circle on this side. All right. Oops, no, this one. All right, and then we need a distance from the origin point here to here. Ooh, excuse me. And then we need the angle. Oh, we can do this. That's right. Train that to that line. Yep, there we go. Okay, let's close that. And then cut a pocket with that sketch. Do 10 millimeters. There we go. All right, I think we're pretty much there. Don't know if we necessarily need to do the USB-C port yet, but we can always add it later as well. Let's just start with this, because this will get us in the right spot and let us know if this is going to be possible. All right. I need the bottom shell. All right, excellent. Let me get into the start view. How do I hide this grid? I remember that being a thing I dealt with last time. Not sure. Excuse me. All right, so we do need to rotate this part on the x-axis. Okay, and then 90. There we go. Wow, it rotated way around the x-axis. Where the heck is the... I tried to draw this so the origin was in the middle of it, but I guess that didn't work out that way, huh? That sucks. All right, that's all right. We can eyeball it. Actually, let's change our units back to inches, as much as I hate to do that. Get back to the unit that we were using. Okay. Is it negative now? Is the part upside down? Oh, it's in thousands. What the heck? I'm so confused what's going on right now. What? Why is the Z not up? The body is relative to the part, so this should still be 0. We just want the part to move. Okay, there we go. Now we're back to inches. So if I... 1... Where does it go? There it is. So the orientations still don't make sense. Okay, yeah it does. It was just weird how it was doing it. Okay. Whoops. Alright, I gotta turn the buttons off while I work this out and get these distances gone. Weird stuff. Okay. Is it really? Do another static fire? That's cool. Disappointed that I'm missing it. Maybe that's why nobody's watching tonight. Everybody wants to see the rocket. Hopefully it goes well. I'm excited to see that thing fly. Alright, that's probably close enough to be okay. The X... Oh gosh, this is going to have to be in the middle and I can't just put it at 0. That's really annoying. Why did this work out this way? I think it's as close to center as I'm going to get. Yeah, right there. Nah, let's go with that. Alright. And then I got to decide how high it needs to be. It needs to get up off this curve. But I want it to be as low as possible. That's probably about good. Alright, so if I look in here, there's a slight gap. It's really hard to see. But it is there. And we are above the point where it starts that curve right there. So I think that's it works. That's basically as good as it is possibly going to get. Now we need to see if it interferes with the buttons. So I'm going to turn off the assembly and then put the buttons back in. Just barely does it squeeze through. Look at that. Wow. Alright, well, I think that's proof that we can use this part. And it might actually, in all honesty, when we actually do this, put a little pressure on it. But I think we can get away with a little bit. This is what I get for making everything to such tight tolerances. I need to... This is what happens when you can't use custom components. When you have to use off-the-shelf stuff, you kind of have to cobble things together as best as you can, and there's only a certain way that everything will really fit. That's why even for pretty small product runs, most people will still do custom enclosures, because it gives you so much more flexibility and it makes the product look so much better and be so much more marketable. All right, so the next step is I got to cut holes on the shell where everything is going to be. So yeah. So we got to figure out how to do that. Which honestly pretty straightforward. It's more about positioning than anything. There we go. And I'll turn this back on. Oh, we're getting so close. And this will time right, because then it'll be next month and I'll have money to buy the stuff when it's time. Sheesh. Really tight fit. Alright. I think I'm going to do that next time. Do all of the holes in the enclosure, because now that we got everything kind of in place, that makes this next part a little easier. Let me go through and double check that there's no extra parts. Turn the PCB off for this one. Washer, washer. Is that screw, screw? Okay, those don't need to be there. Washer, washer. Stand off top, stand off top, stand off bottom, stand off bottom. Stand off there, stand off there. What is this? Screw, screw. All right, and then I think this is the one I wanted. Yep. I want to see real quick the screws that I'm using, if they're big enough. Specifically, these screws. All right. Turn off the... Yeah, all right. That looks good. All right, FreeCAD, turn off. How can I hide the grid? I'm trying to figure out how to turn the grid off so I can have a nice final shot of the whole assembly. Edit, preferences, draft grid, edit. Draft. That's not it. Dang it. How do I hide this grid? More importantly, why is it still there? Oh, set, unset, working plane. There it goes. Okay. That took me a second. All right, let's go back to the start. Oh, surface. Start. There we go. All right. Let's get everything in now. This, and this. Okay, that is everything except the top shell. And then we can add that in as necessary to see the full thing. But there we go. This is our whole assembly on the inside. So we've placed a bunch of parts around, but I think we got there. And then I need to double check that I got these screws added. Standoff screws. Make sure these are the right ones. Yep, 9/16. Okay, yep. Yep. Okay. So next time we'll add the holes on the casing, and then we'll be good to start getting quotes. We'll the PCB shouldn't be that expensive, but we'll need to get quotes from the company that sells the cases, see if they'll be willing to cut 2 of them for us. They will custom cut and print them, but typically when they do that, they're kind of expecting, you know, an order of like 1,000 or 10,000 or something. We'll see if they'll be willing to do 2 for us. And then if so, and it's not too expensive, we'll just have them cut all the holes. If not, then I'm going to have to do it manually. And I'm not sure how I'm going to do that yet. It probably involves a Dremel and a cutting wheel and some drills, but we'll figure that out when the time comes. So, yeah. I think that is it then. No bounties paid out tonight, so we'll see if anyone claims it. I'll leave them up for next time then, and we'll see if anyone claims them. Hope you all have a good night. Thank you for your help, and I will see you Thursday. Bye.